Okay, this is video lesson 1.2.3, and what we're working at in this lesson is introducing exponents for the first time, which is really repeated multiplication. So I have three samples here, and we'll kind of like talk about what's happening in the problem and show how we can build the equation from that. So let's take a look at the first scenario. A population of mice quadruples every 6 months. So what does quadruples mean? That means it's being multiplied by 4. So if I had $10 and I quadruple my money, I would now have $40 every 6 months. Okay. If a mouse nest starts off with 2 mice, how many mice would there be after 2 years? Okay, now notice the first thing we have to do is recognize it was first given to us in 6 months, and now we're talking about years, so we have different labels. Write equation and use it to solve the problem. So here we have, let's just kind of talk about, on day 1, we have 2 mice. And then after 6 months go by, what happens to that mice? Well, we take the 2 mice and then we quadruple it, so we times it by 4. Okay, and then notice we get 8. Then after 6 more months, so now we're 12 months into it, we now have 8, which is, the 2 times 4. I'll just show it like this. And what do we do with that number? Well, we quadruple that number. So we take 8, quadruple that, and notice we get 32. Okay. Then another 6 months go by, and then we have now 18 months. So now I have this 2 times 4 times 4, 32 number, and then we quadruple that. So 32 times 4 is going to be 128. And then 6 more months go by, now at 24 months, and we're at, let me write this out here, 2 mice, so we times it by 4, times it by 4, times it by 4, 3 times, and we take that number and we multiply 4 again. So we take 128 mice, we quadruple it, and we're at 512 mice. Okay, so I kind of logically went through it. Now, a lot of us are saying, well, I can do that, but let's say, how long does it after 100 years? Well, you don't want to do this time and time again to get to 100 years. So we have to come up with a formula to simplify this equation. And that's the whole point of this. Can we translate to a math equation and let the math do the thinking for us? Now let's kind of look at our numbers. So I'm looking at this set of data that I came up with. And notice we started with 2 every single time, and then we multiplied by 4 every time. So we started with 2 mice, and then we took that number and we multiplied it by 4. Now how many times did we do it? We multiplied it by 1 4, 2 4, 3 4, and 4 4s. So 4 4s. So it looks like this. Now, whenever we repeat multiplication, that is the same thing as an exponent. That's what exponents mean, repeated multiplication. So you might want to write that down. So notice this is what our answer is. Okay, so we have a formula that shows that. So a lot of times we'll see it like this. And let's kind of talk about the pieces. The A is what we start with. Okay. B is the multiplier. And then X is how many times. Okay, and I call this the interval. My pen's kind of slowing down here. Okay. And then Y is at the end, the output. Okay. So I'll put end here and output. So I use different words for it, but that's what it means. So we could talk about input and then output. What I start with, I multiply it several times, and I get an answer at the end. So let's kind of think about those pieces. So I'm going to erase this data for right now over here and show you mathematically how we use the equation to get the same data. So we want to figure out how much we end up with. So we started with 2 mice, and then we quadrupled that mice, and we did it 4 times. Now, how do I get to 4? And again, so I plug this into my calculator, we're going to get 512 like we did. Okay. Now, why do we get to 4? Well, think about it. I always think about it. A lot of people are like, what do I use the 6? What do I use 2? You're not looking at the numbers. The numbers are different labels, so you have to mean how they relate it. How many times does 6 months occur in 2 years? Well, we should be able to take 2 years, and we should know that there are 12 months in a year. So if you take 12 months per year times a year, use unit conversion, and we saw a video on that, we should get 24 months. okay? And it says for every 6 months, we have an interval. So in 24 months, 6 months occurred 4 times, 24 divided by 6, okay? So sometimes we'll see this x in different equations as x divided by t, and how many times and so forth it happens, okay? So that is the different intervals that we're doing. So it's not so much like how do we use the 6 and how do we use the things like that, or it's talk how many intervals happen. For instance, the example that I used for a lot of students in class was if I was to pay you every 2 hours and you worked for me for a total of 10 hours, how many times did I pay you? And you're going to tell me 5 times. So it's the number of intervals that are repeated, okay? Let's take a look at another example, okay? In a sports tournament, teams are limited after they lose. The number of teams in the tournament decreases by half each round. So again, 2 teams play, one wins, so 1 advances. So half of the 2 teams advance. Kind of makes sense. If there are 16 teams left after 3 rounds, how many teams start out in the tournament? So again, let's start with the equation, y equals a bx. Okay, what we end with, what we start with, the multiplier, and how many times. So let's plug in what we know. 16 teams left, so that's at the end. So the 16 goes over here. What do we start with? Well, that is the question, okay? So we're going to leave that as the variable. The multiplier is we started with teams, and we take half the number of teams each round. And the question is after 3 rounds, so that is the interval. So notice we now have an equation. So the purpose of this equation is plug in what you know, find out what you don't know. We don't know A. So to solve this, we take 1/2, raise it to the 3rd power, so use your calculator, and you're going to get 1/8. Okay, how do you undo this? You multiply both sides by 8, the reciprocal, okay, and notice those cancel, and an 8 times 16 is going to be 128. So those 128 teams to start the tournament. Sounds like the World Cup here, okay? And then after 128, so let's think about it. So you start with 128 teams, you cut it in half, and you have 64 teams after 1 round. After 2 rounds, you cut it in half again, and you get 32. And then after the 3rd round, you're going to have 16. So we can kind of logically see how the numbers support the equation. Okay. So again, we're focused on how we write an equation that supports the numbers. Okay. This is a lot. As the problems get harder, this becomes more and more reliable. Okay. So let's take a look here. Whoops. Let's take a look at the 3rd example. Okay. Now this one has a different formula. So let's kind of talk about what happens here. The population of a small town increases at a rate of 4% per year. If they currently have 6,000 residents, how many residents will there be in 5 years of right now? So the equation we use for this one looks like this. And a lot of times we don't even use a y here. Let's kind of use what we typically see. And it looks like this. Now let's identify the pieces. The P is kind of like the A from the last example. That's what you start with. You always start with something. So you always have a starting value. Now the reason why it's 1 plus r is because the 1 means you keep the original population. And then you add the increase. Okay, so you add the rate. If it was declining, this would be a negative. Okay. And in T, and again, this happens year after year, so that's repeated multiplication. So that's your interval. In this case, time. And an A is the population at the end, the outcome. Okay. So let's kind of plug in our pieces. We want to figure out what happens after 5 years. So we start with 6,000 people. We keep that 6,000 people. So no, 6,000 times 1 is 6,000 plus 3%. So we add 3%. And then it happens for a total of 5 years. So notice here we add those two together. So we have 1.03 as your multiplier. Okay. So let's just kind of look at that term. So we had some questions in previous examples in the book. If we take 1.03 and raise it to the 5th power, this becomes 1.16, and then, several decimals with I rounded it. So notice it's really increasing about 16%. We call it compounded growth, okay? And so we take that 6,000 and then we times it by that 1.16. Now, I don't round, I just use the calculator to do it for me. And our population after 5 years is 6,955. And again, 0.6. Now we can't have half a person, so I'm just going to truncate it and round it down. So after 5 years, we have almost 7,000 people. Okay, and so the way it looks is, let me write it out what happened. We started with 6,000 people, and then we multiplied it by 1.03. So when we get that, I'm just going to do that on my calculator. We get 6180 after 1 year. Okay. After 2 years, we take that number, 6180, and we times it by 1.03 again. Let's use my calculator. So we times it by another 1.03. And now we get 6365.4. Then we take that year and we multiply it again. Okay, so notice I'm just repeating this. So as 5 years go on, this is what it looks like. So instead of showing the repeated multiplication, we can simplify all of this as this value here. And that's what we call exponents, repeated multiplication. And then this number grows, grows, grows until we get to 6,955. Okay, so those are the different elements that we want to do for this lesson.